So today we're going to be learning how to graph what are called linear inequalities. So let's talk about first what makes an ordered pair a solution of a linear inequality. Linear inequalities are inequalities that have both an x and a y variable. So linear inequalities have both x and y variables. What makes one of these inequalities have a solution? Linear inequalities will have lots and lots of correct solutions. For example, if I take, for example, the point 0, 0, in this ordered pair, the x is 0 and the y is 0. So if I substitute those numbers into this example, 0 is less than 2 times 0 minus 3. If I simplify this, 2 times 0 minus 3 would give us 0 is less than negative 3. Since 0 is not less than negative 3, we would say that this ordered pair is not a solution. But let's take the ordered pair negative 5, 0 instead. If I take this new x and this new y and I plug them in, I should switch that. Positive 5, 0. There we go. If I take this new x and this new y and I plug them in, I get 0 is less than 2 times 5 minus 3, which gives me 0 is less than 2 times 5 minus 3 would be 7. Since 0 really is less than 7, we would say that this ordered pair is a solution. Now, every one of these problems will have lots and lots of solutions. So, just like we've always practiced graphing inequalities on a number line to visually represent all of those solutions, we're going to practice graphing these types of lines on a big grid to represent all of those solutions. First, let's try this. Tell whether the ordered pair is a solution of the inequality. So let's plug it in. Again, this is x and this is y. So I'm going to plug that in. I get 0 minus 3 times 0 is less than or equal to 6. Now 0 minus 3 times 0 gives you 0. So since 0 really is less than or equal to 6, we would say that this is a solution. Let's try another example. So we've got x and we've got y. If we plug those in, we get 6 minus 3 times negative 1 is less than or equal to 6. Now 6 minus 3 times negative 1 makes 9. 9 is not really less than or equal to 6, so we would say that this is not a solution. We can come back tomorrow and do examples 3 and 4 if you're still having trouble, but really all you're going to do here is plug in numbers and see if they actually make a true answer. How do we represent all of the answers for a problem with 2 variables in it on a graph? Now, a number line doesn't work anymore. Because we have 2 variables now. Which means instead of using a number line, we're going to be graphing these lines on a big grid like we did when we learned how to graph lines that had equal signs, only now they're going to have inequality symbols. The first step is to isolate the y variable. Now that means you may need to do some rearranging, so really pay attention to things like adding, subtracting, multiplying, and dividing to get y by itself. Then, after that, you graph the line like normal. So you are going to graph the Y-intercept, which is the b value, and the slope, which is the m value. Again, this is something we've already learned how to do. We put a bunch of points on the graph. Only in these problems, we're not always just going to connect the dots. Sometimes we're going to use a solid line, and sometimes we're going to use something called a dotted line. So, we use a solid line when there's an equal to symbol. And we use a dotted line when there's a less than or a greater than. We are not equal to. After you decide whether to use a solid line or a dotted line, think about a solid line as being like a closed circle, it's all filled in, and a dotted line as being like an open circle, it's all opened up, there's holes in it. Once you've decided whether to use a solid line or a dotted line, the last step is to decide about shading. Now, when we were graphing these on a number line, we decided between left and right. We said less than is left and greater than is right. But since we're two-dimensional now, instead of choosing between left and right, we're going to be choosing between up and down. We are going to shade above the line when it's a greater than or equal to. And we are going to shade below the line when it's a less than or equal to. So greater than means above, less than means below. Let's summarize it like this. Solid lines have an equal to. Less than or equal to, and greater than or equal to. And they're literally solid, like this box is solid. Dotted lines are not equal to. So, like a less than or a greater than. And they're literally dotted lines like this box. Shading above is when you have a greater than or equal to. Remember, greater means bigger, so up. Shading below is when you have a less than or equal to. Remember, below means less, so down. Let's do an example. So the first step here is going to be to isolate the y. I'm going to start by subtracting the 2x on both sides. And I get negative 3y is less than negative 2x plus 12. Now I'm going to divide by negative 3 on all of the terms. Right away I notice I'm dividing by a negative, so my inequality symbol needs to flip over. I also notice that I have a negative divided by another negative, which makes a positive 2/3, and 12 divided by negative 3, which is negative 4. Now I'm going to graph the y-intercept and the slope. So the y-intercept would be negative 4. From there, rise 2, run 3, rise 2, run 3. I could also go down 2, left 3, down 2, left 3. Now I need to decide whether to use a solid line or a dotted line. In this problem, there's a greater than, but we're not equal to. So what I'm going to do is line up my straight edge, but I'm just going to make this a dotted line, like there's dashes in it. The last thing is I need to decide whether to shade above or shade below. This is a greater than. A greater than means I'm going to shade above. So if you think about this as being sort of like a ramp, okay, it's a slanted ramp, I would be standing on top of the ramp if I was standing up here. I'd be above the ramp. So all I'm going to do is use my pencil or my pen or whatever other writing utensil I have and just sort of shade in by putting slashed lines in that portion of the graph. Now what that means is that any point in this portion of the graph is going to be one of those many solutions that we talked about. So we said there are going to be lots and lots of solutions to this problem. We represent them by shading to show where they would be located on a graph. Let's try a few more examples. All right, so in problem number 1, the good news is that the y is already isolated. It's already by itself. So we can jump straight in to graphing the slope and the y-intercept. Now the b here would be negative 3 and the slope would be 4. Now, I sometimes like to write 4 over 1. I feel like that helps. I'm going to start at the negative 3, and from there I'm going to go up 4 over 1, up 4 over 1. I could also go down 4, left 1. Next, I need to decide between solid and dotted. So I'm going to make this line dotted because I'm not equal to. So I'm going to line up my straight edge, and I'm going to make dashes instead of a nice solid line. Last but not least, I need to decide between above and below. I'm going to choose to shade above because it's a greater than instead of a less than. So shading above means if this was a hill or if this was a ramp, where would you be on top of it? I would be on top of the ramp on this side of the graph. So above means this side of the graph. Let's try number 2. So for number 2, I'm going to begin at the 1. From there, I'm going to rise 3, run 1. Now, I'm not writing this out this time. If it helps you to make a list over here, like I did on this problem, please feel free to do so. I'm going to make this line solid because this time there is an equal to symbol. So it basically just means draw a normal line through all the dots. Last but not least, I'm going to shade above the line. And the reason I'm choosing to shade above is because there is a greater than symbol here. So above would be standing on top of the ramp, and you'd be standing over here. All right, now let's try number 3. So for number 3, the beginning point would be the 5. And the slope's kind of hiding here. I would go down 1, right 1. There's an invisible 1 there. Down 1, right 1, down 1, right 1. I could also go up 1, left 1. Doesn't really matter. This time I would use a dotted line. And again, the reason I'm using a dotted line is because we are not equal to. So I would go ahead and make a dotted line here. And the less than means shade below the graph. So if you imagine that this is kind of like a hill, you'd be under the staircase or under the ramp or under the hill if you were down here. So I would shade this part of the graph to show that below there are where all of the correct solutions would live. All right, let's try one more. So for this one, I would start at the positive 4. I would go up 1 over 1, up 1 over 1, or I could go backwards, down 1, left 1, down 1, left 1. Now I'm going to make a nice solid line, which basically just means like a normal line. And I'm making it solid because there is an equal to symbol here. And last but not least, I would shade below. And the reason I'm making it shaded below is because this is a less than symbol. Now again, below means like below the hill, below the ramp, below the staircase. I would be below, under the stairs, when I was on that part of the graph. So thank you so much for watching and taking really good notes. I will see you guys tomorrow for more practice.